Okay, last thing we have to learn in this unit is trig derivatives. So fun, so exciting. So sine x, we already learned that the derivative of sine x is cosine x. Cosine x, the derivative, is negative sine x. We already learned this. But what is the derivative of tangent x? Well, tangent is the same thing as sine over cos, right? So we learned how to do the quotient rule. If you wanted to really bad, you could label sine f and cosine g and do the whole quotient rule out, and it takes forever. But you end up with secant squared x. So that's just something you gotta remember. Tangent x goes to secant squared x. If you don't feel like remembering this, you could take 5 minutes every time you see tangent x and do the quotient rule. But that's not very fun. The derivative of cotangent x is negative cosecant squared x. This is just another thing you have to remember. Secant x, you have to remember, is secant x tangent x when it's derived. When you derive cosecant x, you get negative cosecant x cotangent x. These you just have to memorize straight up. I think these two are easy. And if you look, these two are kind of like related because tangent is secant squared and cotangent is cosecant squared is negative. Because remember I said sine was like the default and cosine was like the funky one, bro? Like cotangent is kind of the funky tangent and cosecant is the funky secant. So these are all negative down here. The funky ones are all negative. Yeah. And secant x is just secant x tan x. That's easy to remember because it's just secant secant. And cosecant, same thing, is cosecant cosecant. It's negative because cosecant's like funky. So we're going to go through a couple practice problems, but we'll make this brief. You just got to memorize these, lock them in. But yeah, so we're going to speed through these. Okay, so up right now I have 2 practice problems. So for the first one, we have y equals sine x tangent x. What is dy over dx? Dy over dx just means the derivative. So what is this? This is product rule. Oh my goodness, product rule, so fun. So sine x, product rule, is f prime g plus g prime f, right? So the first step is to label sine f and tangent g. So f prime, which is the derivative of sine x, is cosine x times g tangent x plus g prime, the derivative of tangent, which is secant squared x times f, which is sine x. This is an acceptable answer. You could turn this in, but you could simplify it more because tangent, we went over this earlier, tangent is the same thing as sine over cos, right? So if you rewrite this, you have cosine x times sine over cosine x. So see how these would cancel? This is cosine over 1. So you would be left with sine x plus secant squared x sine x. This you can normally turn in, but if it's a multiple choice and they have it written as something like this, you should know how to like simplify this and convert this. Yeah, so your answer here is either this long thing up here or sine x plus secant squared x sine x. So this would be your derivative for the first one. Now let's look at this last problem. We have tangent x plus 4x plus 3 secant x. This one's pretty straightforward. It's just secant. Sorry. I'll let y'all do it. Pause it, solve it. Okay, now I'll do it. You have secant squared x. You just do it term by term by term. Plus 8x plus 3. What's the derivative of secant x, guys? What is it? Secant x tangent x. Whoa. Yeah, so tan, sine, and cos, you just gotta remember. Otherwise, everything stays the same, and you treat them like normal terms. That's it for Unit 2. We're done. We doing Unit 3.